All right, so today you're going to be learning about independent and dependent quantities from a table. So a dependent variable depends on the quantity of an independent variable, hence independent and dependent. So basically, dependent depends upon what the independent value will be. And so one way I always remember this is x is independent. And then y is the output is dependent. Because the value of y depends on what x actually is. So like, let's say that you make $10 an hour mowing a lawn. Well, to find the total cost, which is your dependent value, you need to know the hours, which is x. And that's what we're learning today. So it says a freight train moves at a constant speed. The distance y in miles that the train has traveled after x hours shown in the table. So x is the time and y is your distance. So this is independent and this is dependent. And the reason why is because the distance depends upon the amount of time that you've been traveling. So if they travel for 1 hour, you go 50 miles, 2, 100, 3, 150. So what are the two quantities? The two quantities in this situation is time, distance. The distance depends upon the time. So the independent is time and dependent is distance. So a freight train moves at a constant speed, same table. So how far does a train travel each hour? So at hour 0, it goes 0 miles an hour, or 0 miles. At hour 1, it goes 50, hour 2, 100, hour 3, 150 miles. So it's going 50 miles an hour. So your equation will be y is equal to 50x. We can skip that. All right, so describe the relationship between the independent and dependent variables. So the table shows a relationship between two variables, x and y, and you describe a possible situation the table could represent. Describe the independent and dependent variables in the situation. So here you says when x is 0, y is 10. When x is 1, y is 11, 2, 12, 3, 13. So basically, it's doing x plus, I don't know why I did that. So it'd be y is equal to x plus 10. So a situation could be is the table could represent Gina's savings if she started with $10 and adds $1 every day. Okay, so this would be the days, and then y would be the total cost. Okay, so here you have when x is 0, y is 15, then 16, 17, 18. So it means it's x plus 15. So y is equal to x plus 15. So you could say the same thing. So Gina has $15 in her account and she saves $1 every time, every day. So that's the reason why it goes up $1 every day. And x would be days and y would be the total amount of money you have in your bank. Here, when x is 0, y is 0. When x is 1, y is 16, then 32, then 48, 64. So you'll be y is equal to 16x. And you can find a situation that matches that. Going, I'm riding my bike, and every hour I go 16 miles. So at hour 0 hours, I'm at 0 miles. But at 1 hour, I'm at 16 miles. At 2 hours, I'm at 13 miles. So x would be the hours and y would be the miles. Then you have a graph. You do the same thing here. So this is 1, 3. So at 1, it's 3. 2 is 6. 3 is 9, and so on. So it's a multiplicative relationship. So it'd be y is equal to 3x. You can do the same thing at, we make this hours, and I can make this video game wins. After 1 hour playing video games, I won 3 games or 3 tournaments, and so on.